Okay, so here we are at 5.3, and we're talking about annuities. Annuities are a sequence of equal payments made at equal periods of time, which essentially means you make payments per month, per quarter, per year at the same time. This is how much time is between each payment. If it's a month, it's 30 days. If it's a year, 365 days. It just depends how much time between each payment. The time from the beginning of the payment, of the beginning payment to the very last payment, that's what you call a term of the annuity. Sometimes they call it a mortgage. The term that you're going to buy, the time that you're going to buy it from beginning to end until the car is finally yours, until the house is finally yours, that kind of thing. Future value is how much you end up paying at the very end. How much you, at the very, very end, how much you're going to have total charge, how much total charge, or even how much your investment gets you. Ordinary annuity means you're going to make the payment at the end of each payment period. So if it's monthly, you're going to maybe pay at the end of each month. If it's weekly, you pay at the end of each week. If it's quarterly, at the end of each quarter, and etc. This is the formula for future value of an ordinary annuity. Now, PMT represents here the payment that you're going to make monthly or weekly, whatever the payment is set up to be. Then this is the parentheses. This is kind of like the annual percent yield. So 1 plus I raised to the n minus 1 over I. Now, this is how much interest per compounding period. So the interest per period is the interest rate overall divided by the number of compoundings, or the number of compoundings per year. So R over M replaces the I in both of these. N is replaced by M times T. Remember, N is the number of total compoundings over the whole period. This M is the number of compoundings every year. T represents how many years. So that's where they get the N from. So what I went ahead and did was, in this first problem, quarterly payments, I want to get some examples here. Find the future value of the following annuities. You have quarterly payments where M is 4, because it's quarterly. The payment is $1,000 each, so the PMT here is 1,000, and then 1.5% is the interest rate, and then the time is in years, so 4 years. And what I had and did was I went into the problem ahead of time, and so you can see my work and you can see the information that's given. This formula, because I is R over M and N is M times T, I replace these values with these values. So I'm going to go with this formula. M and T representing N and R over M representing I in both of these. So it's just really replacing what they're equal to, substituting. And so I took the numbers that they gave me, I took the values, and I put it into the formula. I took these numbers and I put them here. I went ahead and did this previously. And so this is what I got. So notice that I have to put 3 parentheses here. I wanted you to see before I did it. So because this red represents around the whole top. So that's why there's 3 parentheses, one for the bracket, one for the red, and one for the blue. So that's why you get your 3 there. Then I close the first parentheses, here. Then I raise it to this 2 in parentheses, close this one, then minus 1. Then I close the top, then divided by the bottom in parentheses, right there. And then this one is the outside bracket. So $16,457.97. So if you know how much the payment is, and you know how long it's going to be for, you know the interest rate, you can figure out how much money you're going to borrow. So this might be like 15,000 present value. We don't know if it doesn't have present value. So you can actually compute how much you're going to pay at the end by just looking at the payments. And so they use this sometimes maybe for the car dealership. They say, well, I can, your payment, you can give $500 a month, and then they compute it and they say how it works out better for them. They tell you it's better for you, but that's not really true in some cases. And I get it. They want to make commission, but be careful when you go into a dealership or to a mortgage, because they use math. Math is a weapon, I guess. I guess in a good way sometimes. But so if you have semi-annual payments of $3,000 at 1.1% for 10 years, what would the future value be? So let's see if I can kind of squeeze this. I'll turn this a little bit. In number 2, it says semi-annual. So M is 2. The payment is $3,000. The interest rate is 1.1%, which is 0.011. And then the time is 10 years. So t is 10. So you have your values. And again, I'm going to go into this formula. So the future value would be 3,000 times bracket. And I'll make this big so everybody can see here. 1 plus r 0.011 over m, which is 2, raised to the m, which is 2 times t, which is 10. All that minus 1, bracket, divided by I, which is r over m, 0.011 over 2. And so this thing is your formula. So again, I'm going to put parentheses here and here to show you that you need those parentheses in your syntax of your calculator, or your computer won't understand it. So 3,000 times parentheses, 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 1 plus 0.011 divided by 2, close the first parentheses, and now exponential, and another parentheses, 2 times 10, close that parentheses, and subtract by 1, then put the red, parentheses for the red one, then division, then another parentheses, 0.011 divided by 2, close that parentheses, close the whole thing. So you get here essentially, I'll put it in red because I picked up the red pen, $63,240.92. That is roughly the future value here. That's what it's asking you to compute. Okay? So let's do one more here in the bottom. I probably could only, need to only do 2, but I went ahead and put a third one there. Joe invests in an annuity at 3.4% compounded monthly. So you're already given a couple of things there. Monthly, M is 12. The interest rate is 3.4%. Moving the decimal to the left, you get 0.034%. The time is 8 years, so T is 8. And then the monthly payment, PMT, is $600 per month. Okay? So now your future value, again, is the payment times bracket, parentheses, 1 plus r over n, m, 0.034 over 12, r over m, raised to the m times t power 12 times 8, minus 1, close that bracket, divided by open parentheses, r, 0.034, divided by m, 12. And that's what you put into your calculator. So let's see how this works. 600 times 3 parentheses, 1 plus 0.034 divided by 12, close parentheses, raised to open parentheses, 12 times 8, close parentheses, minus 1. Again, should move again, parentheses here and here, divided by parentheses, 0.034 divided by 12, close parentheses, close the bracket, and you get this number. So your future value is approximately $66,088. And if I guess you can put 1 penny, because it goes 0.0094. Again, the computer is very delicate, so you got to be careful what you put into the MyMathLab. By the way, if you get close to a problem and you miss it by very little and you don't feel like they should take off all of it, shoot me an email. Maybe take a screenshot, shoot me an email and show it to me, especially on the test, because you only get one shot at the test. On a quiz or on a homework, you can do the problem again. That's not an issue, so that shouldn't be too bad. But on a test, shoot me an email or shoot me a message if they mark it wrong and you're very, very close. Send me your work. Send me how close you got, and I'll consider giving you more points. I did that, I think. I looked at the first test and I kind of saw a little bit of that. So that being said, let's kind of turn a little bit more to 5.3. And I kind of skipped, went to 5.4 there too. So I have a little bit of both. So let's just go to, kind of like 5.3 here. Find the amount of each payment. Now, if you're going reverse, this is the formula to find the future value. But if you're trying to solve for the payments, you just divide both sides by the whole bracket thing. Okay? So if you divide by the whole bracket, the payment is by itself, and you get future value over the bracket stuff from the previous one. So that's all we're doing. We're going to do the reverse problem. So this one says, if you know how much money is in the future, how much money are you paying per month or per year? How much is your single payments? So that being said, let's see if we can kind of attack this. So using the formula that you see there at the top, again, one thing here, when you divide by a fraction, you essentially multiply by the reciprocal of the bottom. So this I goes to the top. So if it's okay, I'm going to use this formula. It's a little easier to deal with. So the payment for this type, for this problem, would be future value times I. Put the little dot there. Sometimes, again, you don't have to put the dot. Probably less embarrassing if there's no dot. Or I'm sorry, less easier to follow. But now divided by parentheses, 1 plus I to the n minus 1. I'm going to use this formula. But, again, I and n can be broken further. So this is future value times r over m divided by parentheses 1 plus r over m to the m times t power minus 1. So what I'm going to do here is I'm going to put a bracket at the bottom. So this mess is what I'm going to use as the formula. Okay. So in number 4, I'm writing down the values. You might not be able to see it, but let me see if I can scoot up a little bit. Find the payment that should be paid for the following annuities whose future values is such. Future value here is given as 10,000. Monthly means 12. Again, M for monthly, essentially, I'm sorry, not month. M for number of payments per year, so 12. T is for the number of years, 6. And your interest rate is 5.1%. By now, it should be second nature that the decimal moves left 2 places, so 0.051. So these are your values. This is your formula. So let's see if we can put it together here. So the individual payment would be future value times parentheses r over m 0.051 divided by m, all that divided by bracket 1 plus 0.051 divided by 12 raised to the 12 times t power, m times t power minus 1 close bracket. So all of this is going to go in your calculator. Sorry, I should have put it up there so you can see this. Putting the numbers into the formula the way you see it, and I'm going to put it into the calculator. I hope to God I don't butcher this. So let's see here. 10,000 times parentheses 0.051 divided by 12, close the parentheses, divided by double parentheses, one for the bracket, one for the parentheses, 1 plus 0.051 divided by 12, close parentheses, raised to the open parentheses, 12 times 6, close parentheses, minus 1, close the bracket, you get $119.01. So the payment per month is about $119. It's not too bad because you're paying $10,000 in 6 years. So yeah, the payment should be a little low. That's not too bad. Okay. Number 5. Future value is 20,000. Excuse me, 200,000. The monthly payment, again, they use a lot of monthly because normally you pay per month. T is 20 years, and the interest rate is 3.9%, which is about 0.039. Okay. So you have the payment as the future value times R divided by R divided by M, 12, all that divided by bracket, parentheses 1 plus 0.039 divided by 12 raised to the M, 12 times t power 20 minus 1, all that inside. Oh wow, sorry, I didn't realize that. I was writing, I didn't see what was under this thing. Excuse me, so I'm just plugging the numbers the way I see them, and now I'm going to put it into the calculator. So 200,000 times parentheses 0.039 divided by 12 close parentheses divided by double parentheses 1 plus 0.039 divided by 12 close parentheses raised to parentheses 12 times 20. A lot of this is how you put into the calculator, so you have to be careful, obviously. So $551.45. That's your individual payment. And now one more, number 6, future value of 65,000, semi-annual, M is 2, T is 4, and the percentage R is 6%. So future value 65,000. The interest rate is 6%, which is 0.06. The time, 4 years. And then semi-annual means 2. So semi-annual, M is 2. Future value is 65,000. 4 years at 6%. Now you could say that what this is used for is mostly dealerships or places that say, you know what, if I want to make 65,000 off this vehicle and I want to charge them twice a year for 4 years, how much do I have to make his payment be? And so they work backwards. That's what they're doing here. So let's see. That being said, payment is going to be the future value, which is 65,000 times parentheses R over M, 0.06 divided by 2, close, parentheses, bracket, parentheses 1 plus 0.06 divided by 2 raised to the M times T power, 4 times 2 minus 1, close bracket. And so this is what goes in your calculator here. So I don't butcher this one as well. Or 65,000 times parentheses 0.06 divided by 2. All that divided by double parentheses 1 plus 0.06 divided by 2, close parentheses, raised to the parentheses 2 times 4 power. All that minus 1, and then you close the bracket. Wow, this is a big payment. Yeah, $7,300. Wow. 6%. You're only okay. That makes sense because you're paying twice a year, so you're paying about 14,000 a year. Let's see here. 14,000 a year. I'm sorry. 65,000 times 0.06 divided by 2 divided by 1 plus 0.06 over 2 raised to the 2 times 4 minus 1. Yeah, because they're gonna the interest involved. You're gonna be okay. This is where they get you because they throw in interest and taxes and all kinds of stuff. So that's how much you're gonna pay. That's just crazy. But that's just kind of the way how it works. They charge you this much, and then they usually they throw interest because this is what you pay per month, but then they're going to charge you, remember, compound interest. So this averages out to about 56,000, roughly 57,000, but you end up paying about 8,000 on top of that interest. So that is 5.3.